So presumably you've already seen the title slide here that you know that this is important to monitoring your Azure SQL database. For this session, we want to hit 3 goals. I want to talk about why you need to monitor Azure. I mean, the fact is that, Azure SQL Database is a platform as a service. As a platform as a service, Microsoft is providing lots of things for you. So there should be less that you have to do for yourself. But the fact of the matter is that monitoring is one of the things that you are going to have to do, and there are reasons behind it, and we'll talk about those. There's a number of metrics that you're going to care about, and those metrics change versus what you see when you're monitoring other stuff, and we're going to talk about some of the details there. And hopefully we'll make it so you guys can apply some of this knowledge to the things that you are doing yourselves. And that's the general plan of what we're doing today. My name is Grant Fritchey. I work for Redgate Software. I love saying that any chance I get. This is my contact information, YouTube channel, Twitter stream, whatever. If you want to get in touch after today, talk about this or any other topic, I'd be glad to try to answer your questions. And again, for those who didn't hear me when we started, there is a questions pane, and you can type the questions in right there, and I will attempt to answer them as we go through. So please feel free to use that. Or if you want to get in touch with me later, you've got the contact information here. And I'll put this up again at the end of the session. So, monitoring. I mean, the real question is why monitor at all, really? I mean, modern technology, things run pretty well. When's the last time you really had a crash, right? I mean, it's not that big a deal that we need to worry about stuff anymore. Okay, you can't tell, but I'm smiling. Of course we're going to monitor. The core reason we're monitoring is really simple. Monitoring is the basis of knowledge. We need to have metrics collected on our servers before we have problems. We have to have metrics collected on our servers before we're worried about our performance, before any of the issues come up. We need to have knowledge. And the thing is that we cannot do query tuning. We cannot do troubleshooting, performance tuning. We can't solve problems without knowledge. And you can take a guess at what the slowest running query is. Well, it's probably this one. But you don't know. And knowledge is how you make those choices and how you make those decisions. And the fact is that it's not just monitoring for performance. You need to know that things are online and available. That's fundamental to everything that we do. It's not any different just because we've moved to the cloud. There have been cloud outages, and you're going to want to know what the situation is. Is my database online or off? Also, yes, we're moving to the cloud. Yes, we're moving to something like SQL Database in the cloud. And yes, under the covers, it is still 100% without fail SQL Server. And because it's SQL Server, we're going to be dealing with errors. There's going to be issues that come up. We're going to see things like deadlocks, the traditional errors and events that you see within a database are going to come up, and you're going to have to deal with them. In addition to that, there might be errors that you get that are unique to the Azure situation. And so we're going to want to be able to capture those too. Next up, we do care about performance. So we're going to monitor to capture query performance. Now there's mechanisms within Azure, and we can go over a few of those that show you how systems are behaving, what kind of queries are running against it, and things like that. But there are some limitations on that data collected, and so you may want to augment this with other places of capturing performance. You're also going to want to see what do things look like right now. You get that phone call, right? Everyone gets them. That phone call, there's a problem now. So what is it looking like? Also, and this is the most important, we need the ability to compare before and after. Before and after what is the question? Before and after today, because yesterday it was running fine, today it's running slow. Before and after we deploy something. Hey, we put out a new version of the query or made a change to the indexes. So before and after we made that change, how was systems behaving? Before and after the outage, before and after the database restore, before and after whatever moment in time, we need to have historical information in order to compare it to current information. And without that comparison ability, we can't say, yes, in fact, our system is running slower, or yes, in fact, our system is running faster, because we don't have a comparison point to say this now is slower than it was, or this now is faster than it was. Without that comparison, you cannot do that. So you've got to have that fundamental step has to be there. We have to collect enough data to establish knowledge, yes, but then we have to have enough data to be able to make comparisons. And that's really vital to anything we're doing when we're talking about troubleshooting, when we're talking about monitoring for performance, or just generally monitoring for state. We need to know history as well as what's happening now. And so those two things combined are what provide us with the knowledge that we have to do monitoring. I don't see any questions on any of that so far, so everyone is 100% in agreement, and that's the way I like it. Cool. So let's start talking about the differences here, because when we're talking about monitoring Azure SQL Database, it's as much as it is SQL Server, as much as it is, under the covers, that thing that we've been dealing with for 30 years or however long you've been in, working within SQL Server, it is roughly the same. But there are some fundamental differences. And one of them, the big difference, you don't see the hardware. And it's not even like when you're running on a virtual machine and it says, hey, you're using this much CPU, even though you're really not using that much CPU because it's virtual CPUs and blah, blah, blah. You at least have the illusion that it's using a certain amount of CPU. And there are mechanisms to get you down below and see precisely what's happening on the hardware. Well, when we're up here in the cloud, when we're talking about stuff in Azure SQL Database, especially Azure SQL Database, it's a database as a service is the fundamental offering. With a database as a service, we're no longer worried about hardware. Yes, there is billing based on CPU. Absolutely, I'm going to talk about that in a little bit more detail in a minute. But there is also other stuff. And so we need to be able to look at those things and compare them and know what's going on. And the issue is that none of it is specific to the hardware. And so one of the first things and one of the hardest things a lot of people have when they move to the cloud is that moment of abandon. We are no longer looking at hardware. That's not our concern. That's dealt with elsewhere. We kind of don't need to worry about it unless we get, strong indications through our weight statistics, and I'll detail that in a minute, that there is a hardware issue. Probably hardware is not the problem unless we're maxed out within the service tier, in which case pay more, get bigger, better, faster, stronger hardware, and off you go. Now, the other architectural difference is it is on the cloud. Connectivity. That becomes one of our mantras. We have to know, even if we're just dealing with a web-based application, so that as long as the Azure service is up, our application should be up, our database should be up, and the connectivity to that database should be available. But because it's still the internet, if your internet connectivity is down, problematic, sketchy, you may lose connectivity. And that becomes a very fundamental part of what we're talking about when we start talking about monitoring in what are probably a hybrid environment. Very few of us are going to be 100% in Azure. Very few of us anymore are going to be 100% on premises. Instead, we're going to be in a mixed situation, and that connectivity becomes even more vital because of that issue. Now, remember, this is Azure. And so therefore, we're not controlling the operating system, as I said. We're not controlling SQL Server directly. We have some input into some settings, but by and large, what we're talking about is we have a database. And because it's a database, Microsoft gives us certain views into that data and information, and we only have the information that Microsoft provides us. One of the things you will have to surrender is this, oh, well, I can always, even if I don't have SA privileges, the SA information is there. I can have someone get me what's happening down low level on the server. Well, not here, because we're only going to get what Microsoft gives us. So that is a limitation that we have to deal with in what's going on. But here's the good news. The good news is most of the tools we know today are going to be applicable here within Azure. So if you know how to query the DMVs to pull out information from Azure, you can get it. That stuff's going to be right there. It's going to be available. So there's no surprises, no shocks. If you know how to set up extended events, you can do that within the Azure SQL Database. So you can get query behavior. You can capture this stuff. Best of all, and probably why you're here today, the third-party tools are still out there and still available. So something like SQL Monitor can consume information from Azure, and we'll get into how that works here in a little while. But basically, there are architectural differences. It does cause limits in what you're going to be able to get and consume, how you're going to consume it, and certainly how you store that information for historical tracking. So a lot of stuff is going to have to be done to deal with collecting all that data and putting it someplace, unless, of course, you're using a monitoring tool. Now, one question did come in. If you are in Azure SQL Database using Elastic Pools, where the eDTU is assigned to a given database, and it goes up and down as a function of how busy a database is, does that affect query tuning? Absolutely fascinating question. And the shortest possible answer is no. It doesn't affect query tuning directly at all, because you're dealing with, in terms of query tuning inside Azure SQL Database, you are not dealing so much with the settings that are going to affect query plans, because it's all database internals. So except for things like changing the ANSI settings and stuff like that for the connections, you're not going to see a whole lot of changes because it's within a given database. So even though it's in a pool, even though it's in an eDTU, and those may or may not be assigned up or down, that's not actually going to hurt or change the way we do query tuning. The long-running query is still going to be a long-running query. You're going to look at the query, at the plan, and yes, you can capture execution plans straight off Azure SQL Database. I'll show you one a little later. You're going to look at the query, the plan, the structures, the statistics, all of the same old stuff that you would be looking at, but only within the database. You don't have to branch out into the server, branch out into the disk management system. We're only going to be looking at the database. But then that means that just because you've assigned more or less eDTU, will that affect query plans? And the short answer is no, it won't. Unless there is a way to get it so that it's only got a single processor, and then parallelism isn't possible, and therefore da-da-da-da. But that's a totally different issue, so not directly in effect for your question. All right, so thanks a lot. That was a good question. All right, any questions on this stuff? No? Cool. All right. So when we start talking about Azure SQL Database, it is my favorite topic, one of my favorite topics within Azure, is the platform as a service aspect of it, because it is such a fundamental shift. It is that moment of surrender of going like, yeah, I kind of don't care about backups that much. I'm going to let them handle it. I kind of don't care about the server that much. I'm going to let them handle it. They've got it online, they've got it available, and it's going to be just the database as a platform is all I care about, is the database itself. And then once I've decided I'm dealing with a database, then it just becomes I start making architectural choices. So there's a database, cool. Is it a standalone database? awesome. That's one setup, one mechanism of management, and certainly, more importantly, one mechanism of billing. Or am I going to start looking at pools? And pools allow me to more or less get my bill in hand. I can say, like, here's how much I want to pay every month. And then from within that pool, I can assign it out to multiple databases and decide which ones get to consume the resources that we define, depending on the pool that we define. So that's really just architectural decisions. The behaviors of the monitoring, the behaviors of the databases, and certainly the behaviors of the queries within the databases are not affected by whether or not it's in a pool or inside of a standalone database. Either way, the behavior is all the same. And so the metrics that you're going to gather and uptime and all that stuff, it's all going to be identical. The only real concern is a billing question, in that if you are looking at a pool, you're looking at how much of the eDTU of the pool has been used and by which database. That's really the only real difference in the monitoring between the pools and the single database. Other than that, it's pretty much the same behaviors across the board. All right, so any other questions on architecture? Nope. Cool. So there's a whole bunch of different aspects to the billing, and the billing is actually part of what we monitor. You actually have to keep an eye on that. You want to know, how am I getting billed? And then based on what I'm getting billed, how does my look at the view compared to their look at the view? Are they the same or not? And if they're the same, great. And if they're not, there's a problem. But you're going to pay for it generally by DTU. It's Database Transaction Unit. It's defined by Microsoft, and can be redefined by Microsoft on the fly. This is one you have very little control over. It roughly correlates to CPU use and I/O, but it's not a direct connection to that. It roughly correlates with the level and size of transactions that you have, but it's not a direct correlation to that. It's sort of an independent measure that Microsoft's got off on the side. Now I know a couple of people have gone off, like Andy, oh gosh, I forgot his last name. AM2, Andy Mallon. And Andy Mallon did some measuring where he literally tried to get an equivalent between DTU and CPU, DTU and I/O, and he got pretty close. It was mathematically consistent, but then I think Microsoft changed the formula internally, and so somebody would have to be constantly redoing that. So I generally don't worry about DTU. I just say it's DTUs, and then we're meeting them or we're not, we're up or we're down, and we're done. Now, as far as vCore goes, that's much more direct. It is talking about the number of cores you have and how much of the CPU you're using, how big they are, how fast they are, and it's very directly correlated to the amount of CPU you use. So that one's simple to track and simple to start talking about in terms of what we monitor there as we monitor CPU usage. I mean, it's just kind of pretty straightforward. And then the other thing you're going to have is the geo-replication. Now, the key here is that any given Azure SQL database has more than one database. There's 3 databases actually inside of a data center, and you can pay a little extra money to ensure that those things hop across servers and are stored in separate areas physically. In case just one building goes, you can have insurance that there's a fallback immediately to another building within that data center. All kinds of stuff like that you can do. But the fact is if a data center goes away, so does your database. So Microsoft's got this thing called geo-replication. Now you pay more for it, but what it does is it ensures that you've got multiple copies of your database distributed around to other geographical regions. Now, why are we talking about this from a monitoring standpoint? Very simply, you can query those databases too. So you can have those databases be read-only in another environment, in another location. So you've got your data stored, say, in East US, and you do geo-replication to West US, or you've got your stuff in one of the German data centers, and maybe your data can cross the international borders, so it goes to another data center in Australia. I mean, again, your data, your problem. I'm not going to get into whether or not we're violating German law or GDPR. That's a different discussion. But you get the idea. You're going to pay for this geo-replication, but because of that, you are going to be able to want to watch to see how people are accessing these other databases and keeping an eye on those as well. So that's the other thing we're going to be looking at. Now, how do we do monitoring in Azure SQL Database? Well, a lot of the stuff is as written. Sysdm exec query stats is sysdm exec query stats. Sysdm exec execute sysdm exec text. No, sysdm exec query plan is still sysdm exec query plan. You can use availability zones for data center redundancy. Yes, that's true. That's redundancy within a data center. You can do that. Yeah, you pay a little extra for it, but you can do it. So anyway, sorry, the question came in. I just wanted to make sure I repeated it and told you guys that I agreed with what they said. So anyway, a lot of the internal stuff that we're going to monitor is pretty standard. Some things are different. For example, sysdmdb resource stats, meaning how many resources is my database using, specifically DTU or vCore. How much of the resources is this database consuming? So if we are in a pool situation, we can compare it. Or if we're paying for a standalone database, are we at the edge of the service tier it's in? Do we need to pay for more? Or do we have lots of overhead on the service tier and we could pay for less? I mean, so there's lots of choices there, but sysdmdb resource stats is how you're going to gather that piece of information. Now, weight statistics. If you look, sysdm OS weight stats is available. You can query that DMV just as if you were doing an on-premises monitoring of SQL Server. However, depending on your setup, depending on if you are in a shared environment or not, depending on the service tier that you're paying for, depending on a whole bunch of things, sysdm OS weight stats is telling you information that may or may not be applicable to you. It's not immediately apparent unless you know that you're in an isolated environment, whether or not you're sharing some information. And so that OS weight stat stuff is not going to tell you enough. So they've put in sysdmdb weight stats, which are database specific weight stats. And so it means you have to capture weight statistics database by database in order to have these things and track what's going on inside a given database. Now, personally, I love the metric. I wish this was available inside the on-premises instances. I haven't checked to see if they've added it to 2019 yet, but I know it's not on 2017 or 16 or 14 or anyway. It is an added thing that we have to keep an eye on, but you know, it's available. Now, the one thing that we don't have, do not have, goes away, never to be seen again, and I personally think it's a feature, not a bug. No more trace. No more trace events. No more profiler. You can't capture profiler from Azure SQL Database. You can, however, capture extended events. So if you want to go in and set all this stuff up yourself directly, if you've got a need for doing all these things, you can simply capture the extended events and add them in and see what's going on. RPC complete, SQL batch complete, statement complete, you know, whether batch or SP, all of that stuff for your normal traditional query tuning, it's all available. So it's all there for you and you can get into it and play with it. But you do have to take into account that because it's extended events, you cannot simply run it the way you normally run it because it can't output to a C drive or a D drive or F drive or whatever. So you've got to make sure that when you set it up so that it's got an Azure data storage location to go to. And this means that you're adding some overhead to the cost of your Azure instance because you're adding storage, and the storage is going to affect how you get things done. Oh, and a fantastic question, and I should modify the slide. So the question was, are there no trace flags available for Azure DB? And I should modify the slide, not so much that it's metrics and measures, but there is the one thing we can affect in Azure DB is there is a database state configuration that we can do. And by changing those, we can do things like it's similar to setting trace flags. So if you wanted to say, oh, turn off the performance optimizer enhancements, there's a trace flag that you can set to turn those off. But because we don't have DBCC trace availability inside of Azure, instead, you're going to look up database scoped configuration, right? So you're going to change the database scoped configuration and turn that off. So hopefully that answers that question there. That's not exactly a monitoring and tuning. Well, it's a tuning thing. It's not a monitoring thing because it's not something you use to control monitoring, but it is how you could control tuning. And by the way, you can clear the procedure cache for a database using the scope configuration. You can turn off parameter sniffing for a given database using scope configuration. And just so you know, the scope configuration settings are available in SQL Server 2016 SP1 and above. So if you've got SP1 on 2016 or above, you can use database scope configuration for making changes. Anyway, that's not monitoring, so we're gonna leave that behind and not talk about it for the rest of the day, if that's cool with everyone else. Excellent, no questions. All right. Are there any other questions? Otherwise, it's time to go play. All right, so please forgive me. I meant to set this up ahead of time and I forgot. So I've got to go real quick here and log in. So please forgive me. Sorry about that. Now what we're logging into is the portal, the Azure portal, and you should be able to see that now just fine. Now I've got my Redgate account, and then I have some personal accounts that I can do testing on. What I'm going to show you today is the personal account. So we've got an Azure database that's for Postgres. There we go. There's the SQL database. And yes, I'm working with Postgres and several others as learning. Hang on. While this is loading, Azure SQL is useless. How do you step from database to database in scripts that collect information across a set of databases? Well, one, you can't. You can't use the use database command. However, you can when you're in Management Studio, and I don't have it set up here to demo. Well, hang on. I'll do this for you. I'm your friend. Let's see if I can do it. If I can't, I can't. If I can't, you'll have to forgive me. Okay, cool. And we are set up on SQL DB. What you can do, don't get off my screen, is when we've got a query, you can't use. So that's just not an option for you. And if that's what you need, you're going to have to figure out. I would actually recommend PowerShell, because then you could cycle through the databases that you need through the PowerShell script and run queries against them. That'd be the way to answer that. But the one thing you can do is you can go up to here and type it in, and it will actually let you switch databases. That's actually sort of a bug that Microsoft didn't know about. I mean, I wouldn't call it a bug. I'd call it a feature. But if you type the name in up here, you can actually switch databases. But that's really the only way you can do it. And so that's not automation, right? That's not your friend. You'd want to do PowerShell for this. Okay, let's get this out of our way. All right, so you can see that I've got a database that's been online. There's no real load running against it. This is just my sample database. We're going to be looking at more sophisticated stuff in a little bit. But with this, when it comes up, you can see DTU. Right now, this one's set to DTU, so you can look at it for the last 24 hours or the last 7 days. And you can see when I was running some queries yesterday, I was using, considerably more DTU than it's currently using at 60% of DTU. But I've only got 7 days of information here, so I just want to point that out. And you can see that you can track the storage, and I've used very little. And you do have geo-replication that you can control from here. You have automated tuning, which I have not turned on for the database here just because I haven't started messing with it yet. And from a performance standpoint, you can see the automated tuning. Other than that, what we can do is we can start looking at the performance overview. Give that a second to load because we are live against Azure SQL Database. And with the performance overview, you get some information mainly about what's going on with active tuning, your DTU, your CPU, so you can see what's going on over the last 24 hours. And again, that can go out to 1 week of data. You've got some control over it. Further, you can go in here and you can start modifying this to add additional functionality that if you want to look at some particular counter that it's collecting, you can do that. It's only a limited set of counters that it's collecting. If there's more information that you need, you may not be able to get it. And then you can use the performance insights, the query performance insight, and query tuning. You'll notice there's not that much going on here in this system. I did have a bunch of executions yesterday, but there's not that much in here. But you can look at data IO. Let's go, come on, and log IO. And so you've got a, you know, it's decent, right? It's a decent setup. It's the core. You know, is my server here? Yay, cool. How many queries do I have running? How fast are they running ish? I mean, I can get some information about it, and clicking on it will drill in and show you more. But again, it's a fairly limited data set. But still there. I mean, so, you know, available, you know what I mean? And you can see the data over time. This is largely driven from the query store. If you were to disable the query store here, you would have problems. So have I worked with SQL Analytics in preview? No, I've not. I don't have any suggestions. At this point on the SQL Analytics stuff, it's coming out and it's going to be decent. That's the one thing I will say. Everything I've seen, everything I've read, but it's not yet out there. What rights do I need to run the performance diagnostic tools in the Azure portal? You're probably going to need database owner to get that thing to run properly. So I would, you know, start there, but it's not as friendly as a lot of other monitoring tools are. So there's other informations. And if there are recommendations, we would see the recommendations. There are none for this query, but you guys get the idea. This is the information that we have available to us for a given database. And the thing is that, oops, went all the way back to the beginning instead of the top of the database. And so the thing is that what you have to do is if you've got multiple databases under management, you need to go to each individual database. And then from each individual database, you can see what's going on. Or if you've got pools, you can go into the pool and take a look at it there, and you'll see the pool information. But then if you want to look at what's going on inside a database, you've got to go to that local database again. Or optionally, you guys can build your own monitoring. You guys can take all the information that's here across, you know, you've got 1, 10, 20, 200 databases. You guys can build your own monitoring tool and bring it in that way. And so that way you're no longer looking at one database at a time, You can pull all the information and do it yourself. I, on the other hand, am extremely lazy, hyper lazy. So I don't like doing it that way. Instead, I like Azure SQL Monitor, SQL Monitor for Azure Database, sorry. And yeah, we have SQL Monitor for Azure Database. Now, the nice thing I like about this is what we have right here is this is monitor.redgate.com. You guys could follow along live with me right now and see everything yourself. This is monitoring of SQL Server Central, and those are the SSC monitors. Some example databases out on Azure SQL Database that we are running. We've got some in a pool, you can see here, login pool, or we've got individual standalone databases, or we have another elastic pool right there. I didn't notice that one was also a pool. So we've got a couple of pools, and we've also got a standalone database. And I like my standalone database as an example because I get to see a lot of cool things in it. I use the pools mainly just to talk about pooling. But the standalone database is my friend. It does all kinds of fun stuff. But the really cool thing here is that what we've got is we've got the monitoring set up so that we're capturing data from your local machines, whether they're virtual machines or hard machines, and your Azure SQL database. And we've put it all up into a single pane of glass, a single view into your server so you can see what's going on. Now let's drill down. Let's pick one database and drill down. And here's the key. Remember, again, If we wanted to look at multiple databases and see an overall performance of multiple databases, we couldn't. We would either have to build it ourselves or go through one database at a time. But here you'll notice I've got my 2 pools and my standalone databases all in one spot. So let's drill down on the standalone database. You guys are all hitting it at the same time, aren't you? All right, so this thing is running, and you'll notice instead of the traditional CPU and I/O, yes, we are still collecting the CPU and I/O. Remember though, these are the ones provided through the Microsoft views, not the ones, not something special or different or weird. These are the ones directly provided. Now, this shows us DTU. So we can see the DTU usage in this particular database is DTU driven. So I want to see how much DTU it's using. And so you can see over the time period, which is the last 24 hours, we've got a fairly consistent view, less than 33%, but occasionally some peaks up to about 33%. And that's fairly consistent across both. You can see it within the I/O, within the CPU utilization and all that fun stuff. Now you also see there have been alerts. For example, there was a deadlock. So a deadlock has occurred. Now we're not clearing these like you should be, but what you can see is what's going on here. And because I want you guys to see it. So rather than me clearing it, making it go away, I'm leaving them online so you guys will see the deadlocks and everything as it's going. So we've got block processes that are occurring, we've got deadlocks that are occurring, and all of this is exactly the same as if it was your own database under management. But it gets better. That's the last 24 hours, last 3 days, fine, whatever. Let's remember it goes back 7 days. Let's go back 8. Let's take a look at the 26th. And we have the data from the 26th because we're storing, I think, 30 days online right now. You guys could store more, you could store less, but we've got more data available now because in addition to whatever Microsoft was capturing for us, we're capturing this stuff into a database, and now we've got it available, and so we can access that. Now I'm going to hit refresh and go back to where we were. Cool. Back to March 6th. Now, Azure SQL Database is under the covers SQL Server, right? So it's SQL Server. What do we care about? We care about query tuning. Which queries were executed the most? Well, this query was executed 4,000 times. Which query had the longest duration? Well, this update statement. It's only executed twice, but it is clearly the longest running query in here. Which queries are using the most CPU? Which queries are doing the most physical reads, logical writes? Can we sort it by database? No, but we can at least tell which database it's in. That's all nice, but let's go back to duration here. If we click on a given query, not only do we get the information about the query itself, such as, hey, we want to pull it from cache, here's how you can do it. Would you like to look at the execution plan for this query? Yeah, actually, I want to look at execution plans. Ooh, table scan, followed by a table update. Okay, so I can at least get some sense of what's going on with this query and why it's running so long. And we can't get all the properties and all that fun stuff. These are execution plans, right? And so we can do execution plan analysis and decide what's going on. But it gets better because we show the query, but we show the duration and the history of how often it's run, how much CPU it used, all that fun stuff, and we can make adjustments, and it's for the window range. Further, where is it? I'm missing it. Dun, dun, dun. I guess there's no weights for this one. Normally, we'd also be able to see the weights for the query. Am I messing stuff up? No, I should see weight statistics for a given query. What's going on? Could be that it didn't have enough weights to show up inside the thing. By the way, this is a much more interesting graph of behavior than the other one, but still wonder what caused it to both spike up and drop down in duration here. That's pretty interesting. Anyway, total different discussion. Now, we do capture the top weights, and so you can see the weights that are occurring, And so this is the ones that have the most wait time. If we look at them, we can see if there are queries associated with these. These ones do not have queries associated with them. And these do. So that lock wait is associated with these two queries. And if we look at the query, we can see the query details. And so it shows us all that fun stuff. We get to see both directions. Either look at the waits and find the queries, look at the queries and find the waits. It's all right there. How about memory utilization? Okay, if you want to look at memory utilization instead, we probably can. Let's go back to top 10 queries, sorted by duration. Let's sort it by CPU time. Memory utilization. No, we're not so much doing that. What we do have though is the logical reads and the logical writes. And the logical reads are going to tell you how much memory utilization it has, because every single one of these is the, every time it does the reads here, that's the memory it has to do. So from this view, that's what we have. There are other counters for looking at memory. I haven't gotten to those yet. Also remember, memory utilization is a different measure inside of Azure SQL Database. So we're, again, divorce traditional monitoring from Azure. We need to step back a little bit. Now, the alerts. There it goes. Awesome. So you see, you know that we already had the block process alert. We saw that. And we also talked about the fact that there were deadlocks. Yeah, that's not the one I want. Where is it? Hang on. Let's go back to the overview window. Oh, there it was. Duh, I'm an idiot. Sorry. You practice, and then you forget everything when it comes time to actually do the session. Give it a second to come back up. There it goes. Right. Let's narrow it down and take a look at a particular database. There we go. So now we're looking at a particular database, and we can see the DT utilization alert, long-running query alert, all that fun stuff. Or we can look here and see that, yes, this one had a deadlock event. And if we take a look at it, the deadlock event is going to be pretty much the same stuff as any normal deadlock. We would drill down and see what's going on. Let's give it a second. There it goes. So we get the full deadlock graph. You can look at it in detail. You can rearrange these things however you need to look at it. You can pull the information together, and you've got all the stuff you need to try to troubleshoot the deadlock. You can even see at what moment in time that deadlock occurred. And this is exactly the same behavior as you would see if you were looking at a deadlock problem inside your on-premises servers. Why? Because, hey, under the covers, it's SQL Server. All right. Let me pause for a second because there are a few questions came in. Let's see. Is there any easy way to filter the default views to exclude certain queries? No. Pretty much that's the way it runs. If you need to look at very specific data sets, you can run queries against it yourself. How heavily do DMVs get hit to retrieve all this data? There is a hit, right? Any performance monitoring causes a hit. The percentages that I've been able to measure, it's small. For most systems, under most loads, less than 1%. But again, depends on your system, depends on your load. I have seen it causing more load on a very high-end system, but it varies. There's no straight line formula because it really does depend on what's going on your system as well. Adding adds, will it create objects in the destination database? Absolutely not. We are reading, we are not writing to that database. We do have to have a place to store all the information that you can see here, right? We are capturing deadlocks, all the overview information, all that fun stuff has to go someplace. So you got to provide either on-prem or up in the cloud. My recommendation would be up in the cloud, but you can do it either way. And then make it so we can connect up to retrieve the data. But we do not modify your structures. We don't install anything other than the monitoring tool. So you're fine. And where is it actually executing? It's executing wherever you've installed it. Probably a virtual machine, probably in the cloud, but you can do it locally. But that does mean you will pay for moving data out of the cloud depending on the stuff that we're looking at. All right, let's take a look at the pool. Where's my mouse? There we go. How are we doing on time? Oh, wow, doing really well. Okay, cool. So when we look at the pool, what we get are, there are databases in the pool. So the pool itself shows us this, but in this case, there's one whole database in the pool. I got to talk to these guys because I need a pool with at least 2 databases. What's going on? Hang on, maybe it's 1 second. A pool with 1 database is weird. Why would you do that? Hang on. Might be my fault. There we go. Oh yeah, cool. A whole bunch of different pools. So a bunch of different databases. And as you can see, the pool has a collective behavior, and because you're paying for the collective behavior of the pool, so we have a collective view of the pool. But then you can go down to the database and say, okay, well, per database, how much am I using up? What transactions? How much is the size? And I've got all of that stuff available. Now, that's just all traditional monitoring. The fun thing is that we still have our traditional analysis available for Azure. So we can say, oh, let's see, this is not a metric I want. Let's go find a metric I like. Because we've got the Azure database metrics. So we can say, hey, you know what? Let's go down and say, look at, DTU percentage for both databases. Because we can add another metric and then add it for there. We can add all the metrics and set them up however we want to do it. So we can compare one database to the next, one set of servers to the next, one set of pool databases to the next. You can add these things in as you want to. And then once they're added, you can, you get to play. You get to do it any way you want to. How do you connect to the database? So I need to inform SERP user info. All right, so connecting to the database is a whole different discussion. Have to talk about firewalls, access through the firewalls, all that fun stuff, and whether or not you're using a SQL login or an Azure Active Directory login. Totally different stuff. We don't have time to cover all that. We're going to have to have a completely separate non-Redgate discussion to get to that one. So sorry, who's that? Gabrielle. Sorry about that. Can't answer that question today. Anyway, this is available. Further, we can compare to the baseline. So an hour now versus an hour earlier, or extend the baseline, an hour now versus the last previous 7 hours going backwards in time. Or better still, let's look at the last 24 hours versus the last 7 days. Take it a second for it to load up, and oh, look at that. We can see what's going on, and we can even say, okay, hang on, put it into regions. Let me see what's the general behavior by region, and then look at this one too, the same way, by region or by individual lines. And so we can see that there's fairly consistent behavior across these, mainly because it's a program behavior. How's the license cost for this? Is it per DB? Look, license costs are not an answer I like to give because I'm not very good at it, and 2, you should always negotiate those. So there is a retail license cost. You can get that from the website, but then I strongly recommend make my sales team earn their money and negotiate with them, because you don't want to ever pay retail. Anyway, we've pretty much got all the same stuff that we would normally see, and you can look at reports and reporting, and all of it's Azure database or Azure and your regular queries mixed, either way you want to. The only area where right now there's not a lot of Azure stuff going on is what's called the estate monitoring, and that's because primarily right now the estate has focused on things like versions, backups, agent, and disk usage, none of which exist in Azure. So right now, this aspect of the monitoring tool just isn't necessarily applicable to the Azure database, but that's okay because we've still got you packed right in to the overview. So as part of your entire estate, all of the servers you have under management, your cloud-based servers are marked and available, and you can look at them individually or grouped as needed. And so the estate management, which starts here, and then moves into the estate reporting, which is a different issue. The estate management is still an estate. So it's basically, you know, like I said, a single pane of glass. And look, we had another deadlock occur at 10:41 as we were talking. That's great. Not that deadlocks are occurring. Deadlocks are horrible, but it's great that we're capturing the deadlock so you guys can see it. All right. And that's roughly our demo. So Azure SQL Database needs monitoring. It needs it, but you need to be able to do more and better than just that 7-day limited data set. If you want more and better, we've got it built. So we've got better reporting. We've got a more complete output, and you can see what we've got versus what they're collecting. We have a longer history available, and you can extend that as for as long as you want to store the data. I mean, that's on you to figure out how long you want to put it in there. We've got the analysis capabilities so that you can see that back in time. What did it look like an hour ago? What did it look like over the last 7 hours or over the last 7 days, 7 weeks, however much data you've got collected for, which allows us to do baselining. Oh, and the alerting, you just set up your alerting in here. Hang on one second. Forgot all about the alerts. That's my bad. Let's go to configuration. 1 second. And the alert settings. So we can set up so that we're looking at specific alerts that are only associated with Azure pools or are only associated with Azure SQL Database. And you can turn them on, turn them off, enable them, not enable them. And so this is a very, very easy way to set up alerting. There are about 8 to 10 different ways to set up alerting inside of Azure. Every one is slightly different. None of them is agent, and none of them shares a common set of alerts with your regular databases. And we've got them both set up so that you've got the regular Azure stuff and the regular SQL Server stuff, such as the deadlocks, which you guys already saw. So we saw the deadlocks occur, we've seen the other things occur, and we've got the specific Azure alerting. So combined alerting through a common interface makes things a lot easier. Let's switch back over to the slide so I can finish up that bit. And finally, because of using SQL Monitor, it gives you a hybrid mechanism for managing the differences between your Azure estate and your non-Azure estate, whether that's VMs or physical machines, it doesn't matter. If it's VMs in the cloud, we monitor those as well. Any way you want, we're going to support it across the state with SQL Monitor. Now, all of that said, before you guys go and we start answering any questions that are outstanding, I do want to mention that we've got a couple of events coming up. First up is SQL in the City Streamed, which is taking place Wednesday, April 3rd. It's funny that they've got that on the right and the other one on the left. But SQL in the City Streamed on the right there is taking place April 3rd. It's going to be a live event. Myself, Kathy Kallenberger, Kendra Little, and Steve Jones will all be doing a bunch of presentations along with some other Redgate people mixed in there. Or if you want to meet live, I will be at the London, UK event April 30th, and then I miss the rest of them. There's going to be Los Angeles in the US, Austin in the US, and then 3 events in Australia. Steve Jones is going to all 3 of those. Is monitoring and alerting of corruption. Hang on, we'll get to that in 1 second. So anyway, go to these, check these out. We'd love to have you either at a webinar or at a live event, either one. So hook up with us. Let's see, let's go to the next slide. Hopefully we learned about why we're monitoring Azure SQL Database, because there is a reason to monitor. We talked about some of the tools and metrics, and then I showed you how to do the monitoring. And the fact is that you guys already know most of what you need to know. It's just the differences that really matter. The fact that you're not dealing with that low level stuff. As I said, I'll put up my contact information again at the end, and now I will go back and answer any outstanding questions. And so the first one was, is monitoring and alerting of corruption a topic in SQL Server? Great question. Is it a topic? Yes, it absolutely is. Is it something we monitor? No, we do not. Microsoft is doing that for us. We don't need to monitor for corruption. They will have it available. And if something gets corrupted, Microsoft will deal with it on their end. I myself have not hit any known corruption issues, but that doesn't mean I've not had them, because what would happen is it would fail over internally, and we wouldn't see it occur. It would fail from one database to the other if there was corruption. They've been really, really good at that, and the fact of the matter is I've not heard about any major data loss, except they had a recent outage. I've got a my YouTube channel actually has a video coming out today on the topic. They did have a recent outage in which they lost 10 minutes worth of data for a few databases, but it was pretty isolated, pretty focused. Overall, corruption is not something you will be worried about. You won't have to set up anything for monitoring of corruption. That's going to be completely internal. It's part of that whole platform as a service offering. All right, let's see. Will the demo be made available? Yes, we are recording it, and everything will be available on the recording, so you guys can come back and watch it later. And any other questions? Going once, going twice. Okay. Well, Louise, I think we are all set. Data replication delay can be monitored. Yes, you can monitor how long it's taking for the geo-replication to occur. Your primary friend there will be the wait statistics. You'll want to look there, but that information is available. It's there. Cool. All right, I think we're all done. So if you want to shut it down, we're finished for the day.